Good day everyone, I am Eugene De La Cruz, an ID 123 Civil Engineering student, and I will be discussing BASPHYS LQ2 or Basic Physics Long Quiz number 2. So Long Quiz number 2 covers work, energy, power, impulse, and momentum. So let's first focus on the first subtopics which are work, energy, and power. So let's first define work. So work is the energy transferred to or from an object via the application of force along a displacement. Or in mathematical terms, W is equal to F times D, where W is work, F is the applied force, and D is the displacement. So this formula applies when the force applied is linear or its direction is the same as the direction of the displacement. However, if the direction of the force is different from the displacement, then we simply multiply this by cosine theta, where theta is the angle between the force applied and the displacement. Another formula that we can use is F sub x times T sub x plus M sub y times T sub y, where F sub x and D sub x are the force and displacement along the x-axis, and F sub y times T sub y are the force and displacement along the y-axis. So we can use this formula if we are given the x-coordinates or the y-coordinates of a force or a work. So since work is energy, then the units for work is joules, and force is in newtons, and displacement is in meters. And also, if we're looking for the total work or the net work, then we can simply get the summation of the forces multiplied by the displacement. So the total work is equal to the applied forces times the displacement. So we mentioned earlier that work is the energy transferred. But what is energy? So energy is the ability to do work. It is the ability to exert a force causing displacement of an object. So there are two main types of energy. There is kinetic energy and there is potential energy. So kinetic energy, it is also called as energy of motion. It depends on mass and motion. So kinetic energy, in mathematical terms, it can be written as K equals 1/2 mv squared. So as we have defined earlier, it is dependent on the mass and the motion. Hence, the formula is 1/2 mass times velocity squared. And then moving on to potential energy, there are two main types of potential energy. There is gravitational and there is elastic. So from the name itself, gravitational potential energy is based on the gravitational force. So what affects this energy is the body's weight and the height. So in mathematical terms, U sub g, or the gravitational potential energy, is equal to mgh, where m is the mass of the object, g is the gravitational force, and h is the height of the object. And lastly, elastic potential energy. This is the applied force to a deformable body. So elastic potential energy applies to deformable objects or objects that can be stretched or compressed. So in mathematical terms, it is U sub E, or elastic potential energy, equals 1/2 kx squared, where k is the spring constant and x is the elongation. And then moving on to the next concept, which is power. So we define power as the time rate at which work is done. Or in mathematical terms, P is equal to the work done, or delta W, over the time rate. or delta T. So we defined earlier that work is equal to force times displacement. So we can we can substitute W equals F times T. So power is equal to F times T over T. And we know that displacement over time is also equal to velocity. So we can write this as force times velocity. So the formulas for power are delta W over delta T or F times V. So the unit for power is in watts or joule per second, since work is in joules and time is in seconds. So let's try solving the sample problem. So you decide to move your couch to a new position on your horizontal living room floor. The normal force on the couch is 1 kN and the coefficient of friction is 0.6. You first push the couch 3 meters parallel to a wall and then 1 meter perpendicular to the wall. How much work is done by the frictional force? So in this problem, we are looking for the work done by the frictional force. So we know that work is equal to force times displacement. And by definition of frictional force, it is the force applied in the opposite direction of the force applied. So it is in the negative direction. So to look for the work done by the frictional force, we first need to look for the frictional force. So an important formula for this is F is equal to mu times N, where F is the frictional force, mu is the coefficient of friction, and N is the normal force applied. So from the given problem, we know that the coefficient of friction is 0.6 and the normal force is 1 kN. So from here we can get that the force of friction is 0.6 times 1 kN or simply 0.6 kilonewtons. So we can now get the work done. So the work done by the frictional force is negative 0.6 kilonewtons, and then the displacement of the couch is 3, since it is pushed 3 meters parallel to a wall, and then plus 1 meter since it was pushed 1 meter perpendicular to the wall. So it will be 3 meters plus 1 meter, or negative 0.6 kilonewtons times 4 meters, or simply negative 2.4 joules, or kilojoules since we use kilonewtons. So that will be our final answer for letter A. So therefore, the work done by the frictional force is negative 2.4 kilojoules. And then moving on to letter B, you don't like the new position, so you move the couch straight back to its original position. What was the total work done against friction, moving the couch away from its original position and back again? So what we're looking for here is the work done against the friction. So we know that the work is equal to F times D. The force here is still friction, however, we're looking for the force against friction, so we don't need to apply the negative sign anymore since we will negate the negative, so it will now be positive. So we just copy the force of friction from earlier, which is 0.6 kilonewtons. And then our displacement, so based from the problem, it was pushed from its original position and back again. So we get 3 plus 1 plus the hypotenuse. So it will be 3 meters plus 1 meter plus, by Pythagorean theorem, it will be 3 square plus 1 square. So 0.6 kilonewtons times 3 plus 1 plus, this will be 9 plus 1, so square root of 10, or 0.6 kilonewtons times 4 plus square root of 10 meters. So by using a scientific calculator, we can get that this is equal to approximately 4.3 kilojoules. So that's the final answer for letter B. Therefore, the work done against friction, moving the couch away from its original position and back again, is 4.3 kilojoules. So thank you so much for watching. You may also avail syntax tutorials by scanning the QR code flashed on your screens. And once again, this is Eugene De La Cruz from Syntax, paving your way to excellence.